have the data on which we need to figure out the effects of these variables on the energy output. To do this, I have developed a solution schema where the first question, which the step what the, want the problem wants us to solve is uh, the type of machine learning approach and the appropriate metric. So this is a regression problem since we have to build a model that that can actually accurately predict the power output. And the performance metrics over here, which I have picked up, are the mean squared error and the root mean squared error. I will use RMSE as a primary metric, considering that it is very easily interpretable and it penalizes large errors heavily than the smaller ones. The possible features which I have used over here are actually temperature, uh, ambient pressure, humidity, and exhaust vacuum. What I've also done is that I have taken the interaction between temperature and ambient pressure and relative humidity and exhaust vacuum separately as another variable. The algorithm which I'm going to use is a multiple linear regression. And before I proceed, I have also divided the data into three sets. So the training set, the validation set, and the test set. The distribution between these three is 70%, 15%, and 15% respectively. So before I move into this, I've also randomly sorted this data so that there is no bias in the way I pick it up. I've also figured out a scatter plot to understand the relationship between all these variables and on the energy output. So now going to on the training data set, there are three training models which I have used here. The first one is all the four features on the output. I'm getting an R square of 0.93. Similarly, in the model 2, which is an intersection of between temperature and vacuum, which is this flow, and over here also getting an R square of 0.93. And also in the third interaction, which is between the ambient pressure and relative humidity, which is this row column, and the R square again coming out to 0.93. So the R square value of 9.93 indicates and states that 93% of variation in power plant electrical energy can be explained by the environmental variables. Um, I have I validated this data as well on model 1, on the model 2, and on the third model. Here there is a slight variation which I have observed model in model 1. The RMSE is coming to 6.8, but the RMSE for model 2 and model 3 is coming to 23.81 and 23.89 respectively. Um, this shows that the two models where the RMSE is different is uh, is unstable. It's overfit. It might be overfitting data. There could be outliers in the data, and it could be highly sensitive to certain data sets. But when we move into the testing phase, where I've tested this data set, I do see that uh, the the RMSC is 4.6 for model 1, and for model 2 it is 4.3, and for model 3 it's 4.6. um, so even in the on the test data, I can actually vouch that the environmental conditions are highly predictive of the electrical energy output. um, and there is a considerable relationship between the input variables and power generations. Though I do observe that there are certain um, outliers in the validation data set, but on the testing data set, uh, it is coming out to be a highly predictive model. Thank you.